And this is all about solving an equation that is what they call quadratic in form. So on the project, I show you these two examples, x squared plus x minus 12, factors as x plus 4 times x minus 3, and x to the fourth plus x squared minus 12, factors as x squared plus 4 times x squared minus 3. So this format right here is what's called quadratic in form. So instead of this being x to the first and x to the second, this is x squared and x to the fourth. And really any equation where you've got x to the 2n, x to the n, like that, would be factorable just like a quadratic. Okay? So that's the general idea for this idea of something that's quadratic in form. All right, now because of that, because of the way this works, you can also use the quadratic formula to solve an equation that is quadratic in form, even if you can't factor it. So the example I give in the project is x to the fourth plus 2x squared minus 6 equals 0. We can run this through the quadratic. A equals 1, B equals 2, and C equals minus 6. And if we do that, we get solutions on the calculator of 1.646, negative 3.646. But here's the thing. These are not solutions for x. These are solutions for x squared. So if we want to get solutions for x, we need to square root these two answers. So when we square root this one, we get plus or minus 1.283. And when we square root this one, notice it's negative, so we're going to get a complex answer, plus or minus 1.909i. Okay? So we get 4 solutions. This is x to the fourth, and that's the maximum number of solutions that we can have. There's this thing called the fundamental theorem of algebra that said you can have as many answers as the highest power of x in your equation. So that's the general idea here. All right. So now the project itself starts with part 1, and we get this equation, x to the 6th plus 2x cubed minus 5 equals 0. Okay, so we can run this through the quadratic formula. We'll get 2 solutions for x cubed, and then we need to take the cube roots of those. Okay? If you're not sure how to take a cube root, let me just show you quickly on the calculator here. All right, so on the calculator, where is it? The math key, right there. Come on, can we get some, there we go, some focus. Hit the math key. And then you can see choice number 4 is find the cube root. Okay? So hopefully that will help you. And again, if you get stuck in any step along the way, let me know. I'll be happy to help you. Okay? Let's see here. So we're going to run this through the quadratic. We'll get solutions for x cubed. Cube root them. That'll give us 2 solutions for x. But notice that this is x to the 6th power. That means we have a potential for 6 solutions, but this only gave us 2 of them. All right. So how can we find this out? How can we find those missing solutions? Well, first, what we need to do is we need to think about something that's called a cube root of unity, or roots of unity. Okay? And so the idea here is that we want to find the cube root of 1. Now, if you run this through your calculator, pretty straightforward. Cube root of 1 is 1, right? And the definition here is because 1 cubed is equal to 1. All right, pretty straightforward. Let's see here. Let me actually talk about this briefly with a different example where the numbers aren't all the same, right? We say the cube root of 8 is equal to 2. That's because 2 to the 3rd power equals 8. All right? So that's the same idea. Now, let's imagine that we've got a variable that I call W in the project here. So this is that equation. We're headed towards that equation I was talking about a few minutes ago, and this is the explanation for where it comes from. Okay? So let's say we've got our variable W, which is a cube root of 1. What does that mean? That means when you raise it to the third power, you'll get 1. Oh, okay. That's where that equation comes from. All right. Then the project asks you subtract 1 on both sides. Now we've got W cubed minus 1 equals 0. And now we're going to solve this equation. Okay. The process for solving that equation is described in the project. I'm not going to get into it right now. If you get stuck here and have questions, I'll be happy to talk with you. Okay. It has to do with factoring this. Okay. And then using a solution by factoring process. Again, if you're not familiar with that process, let me know. I'll be happy to talk with you about it. Okay, so that is part 2. Part 1, find these 2 solutions just using your calculator. Okay. Part 2 is find these W's. There should be 3 of them. Okay. One of them is going to be 1. The other 2 are going to be complex numbers, all right? And that's how we're going to generate the other 4 solutions. See, because when we get to part 3, let's see here. Part 3, so let's say we've got a solution x cubed is approximately 1.4495, okay? So, to find out what x is, we're going to cube root both sides. But before I do that, there's always a hidden 1 hanging around in there, right? Because any number is also equal to that number times 1. All right. So now we're going to cube root both sides. And this will give us x over here. Here we'll have the cube root of 1.4495, but we're also going to have a cube root of 1. Okay? So, when we go through the process in part 1, and this is actually what's happening in part 1, so this will give us 1.1317 for the cube root of this number. Cube root of 1 from the calculator is just going to be 1. And so that's going to give us this 1.1317. Okay? So here's the thing. In using your calculator to cube root this, you lose the complex roots. Okay? So this is going to be one of the 2 roots that we're getting in part 1. Now, come back to the answers that you got from part 2, because there's 2 other cube roots for 1. Going to do 1 here and 1 here, and that'll give you 3 solutions from this process. Okay? The second root that you find in part 1 will go through the same process. You'll get 1 root with just a 1 as the cube root. Then you've got these other 2 complex cube roots. That'll give you 3 additional solutions. 1, 2, 3, 4, 5, 6. We'll have all 6 solutions.